If you, like me, could use some good news, I got some for you. So this month, humanity reached a very cool milestone, which is that we have now discovered over 6,000 planets in other solar systems. This is absolutely amazing, you guys. We didn't discover the first type of this planet until 1992. So when I was born, we didn't even know if there were planets around other stars. I mean, yeah, like we kind of thought there were, but now we know. In fact, we know they're fucking everywhere. So let's talk about how we do it, just very briefly. Okay, so this big purple section, most of the ways that we detect planets is via the transit method. So this is basically a planet transiting in front of a star. So if we look at the star, the light from the star will dim just a little bit when the planet passes in front of it, and then we know that there's a planet there. The green, so this used to be the most common way to detect exoplanets, is called radial velocity. And so in this case, we're looking at the star and we're measuring its motion. And because the planets around a star affect its motion via their gravity, we can detect these little tiny wobbles, and that tells us that there's a planet there. Microlensing has kind of been growing a little bit, especially in recent years. This is really cool. So this is basically using gravitational lensing to detect planets. And yes, these are really small objects, and so the signal is like this little tiny spike in light when everything aligns just right, and then you know that there's a planet there, and that's pretty cool. Imaging, so this kind of yellow streak that you can see, that is from direct imaging, and so that's exactly what you might think. That's literally taking a picture of the planet itself. You have transit timing variation, so if you look at these transits, you expect them to happen really regularly for something that's in orbit. But if there are other things that are in orbit, it can change those orbits just a little bit, and so you might discover other planets in a system based on how the timing of the transits changes. Same thing with eclipse timing variations. Orbital brightness modulation, this is kind of crazy. So this is basically as a planet goes around its star, it reflects a different amount of light depending on what phase it's in, and so sometimes we can detect that change in the light of the star. Pulsar timing, this is actually how the very first exoplanet was ever discovered. Pulsars have a very regular pulse that they release, and if there's a little bit of motion, it can change that timing of those pulses, like from gravity from a planet, and so then you know that there's a planet there. Astrometry. So this is kind of the other dimension of radial velocity. So radial velocity is looking along the line of sight, radial, either motion towards or away from you. Whereas astrometry is kind of looking in the 2D plane of the sky. So how a star is moving across the sky, and sometimes there's little wobbles in that movement. That is because of a planet that you can't see, but you know it's there. Pulsation timing variations is kind of like pulsar timing, except instead of looking at pulsars, which are neutron stars, you're looking at pulsating stars. And then lastly here we have disk kinematics, and this is really cool. So if you're looking at a protoplanetary disk, in the gas and dust of the disk, a planet can make this really distinctive kink in the kinematics of the disk, so in the velocity of the gas and dust in the disk, and then you know that there's a planet there even if you can't directly see it. So these are all the ways in which we have discovered exoplanets, and now we have done that for over 6,000 exoplanets.